Good morning, students. Today we are going to discuss exercise 9.5 continuous fourth question. So the question is, at the given point x0, discover whether the given function is continuous or discontinuous, citing the reasons for your answer. So we are doing first subject. X0 is equals to 1, f of x is equals to x square minus 1 by x minus 1 if it is x is not equal to 1, and 2 if x is equal to 1. So it is asking us to check the continuity at one value. So at x is equal to 1. First let us find out the left hand limit. So that is limit x tends to 1 minus f of x. So limit x tends to 1 minus, that is x square minus 1 by x minus 1. So this function can be written as, so for simplification we will solve here. X square minus 1 can be written as x plus 1 into x minus 1 divided by x minus 1. So x minus 1, x minus 1 is cancelled. We can use x plus 1. That equals to limit x tends to 1 minus x plus 1. If I substitute 1, so 1 plus 1 which is 2. So now if I talk about right hand limit, limit x tends to 1 plus f of x is equal to limit x tends to 1 plus, so more than 1, it will take in the same function which is x plus 1, so that is 1 plus 1 which is 2. So here left hand limit equals to right hand limit. So we can say that the function is going to exist. Sorry, the limit is going to exist. So whether, let me check whether, so I can write now whenever HSL equals to RHS, we can simply write that limit x tends to 1, f of x is equal to 2. We got this value. Now let us check whether the functional value is at f of 1. So if I substitute at f of 1, at function at one value is 2. Therefore, we got limit x tends to 1, f of x is equal to f of 1 value. It means that this value also 2, this value also 2. So limit value is equal to the functional value, then we can say that therefore as x0 is equal to 1, function is continuous. Function is continuous. Now let us look at the sixth question. For what values of alpha is the function given function is continuous at x equals to 1? So in the question itself we is saying the function is continuous. What does it mean? It means that the limit x tends to 1 in the continuous at 1. So limit x tends to 1, f of x, the given function is equal to the functional value. So this is by seeing the given statement solution. By seeing the given statement we can say that limit value is equal to the functional value. So if I simplify my functional value here, limit f of x at 1. So limit x tends to 1. So I will use this value, that is limit x tends to 1. So if I simplify this, it will become a square minus b square divided by x minus 1 is equal to f of 1. At 1 it will be alpha, it will be alpha. Next step, limit x tends to 1. It is in the form of a square minus b square. We can write it as a plus b into a minus b divided by x minus 1 equals to alpha. So in the further step, limit x tends to 1, x square plus 1. Again we can split it in terms of a square minus b square, but we can write it as a plus b into a minus b divided by x minus 1 equals to alpha. So x minus 1 gets cancelled. Now if I substitute this value in place of limit x, if I substitute 1, it will be 1 square plus 1 which is 2 into 1 plus 1, 2. So the alpha value is 4. Let us see the seventh question. Let f of x is equal to 0 if x less than 0, x square if 0 less than or equal to x less than 2, 4 if x greater than 2. We need to graph the function and we need to show the function is continuous for every real number we need to show. So first let us start to draw the graph here. First, x less than 0. If x values are less than 0, automatically it will be negative value. So negative value, each and every value will be 0. So this is 0. Apart from 0, the remaining all values are negative. So the graph will be like this. Next, at 0 to 2, up to from 0 to 2. From 0 to 2, it is y, it is like a x square value, so it will be like a parabola. So it will be from parabola. Y is equal to, it will be parabola. Next, at this phase, x greater than or equal to 2, at the 2 as well as more than the 2 values, it will be only 4 values. It is normal straight line. So this is the graph. So we are having a 2 points, we need to check the continuity at 2 as well as at 0. So first let us check the continuity at x is equal to 0, as well as next let us check the continuity at x is equal to 2. At x is equal to 0, so left hand limit x tends to 0 minus f of x is equal to limit x tends to 0 minus. If I take less than 0 values, less than 0, so the answer is 0 only. So the answer will be 0. Next, if I take right hand limit x tends to 0 plus f of x. So that is more than 0 value. More than 0 value is x square. So which is 0, again it will be 0. The functional value f of 0. So 0 is equal to, it will be again 0 square, which will be 0. Therefore, your left hand limit is equal to right hand limit is equal to the functional value. We can say that the function is continuous. Therefore, at x is equal to 0, the function is continuous. At x is equal to 0, the function is continuous. Next, let us check for at x is equal to 2. At x is equal to 2, left hand limit. So if I take left hand limit x tends to 2 minus f of x. So less than 2 values, so it is greater than 2, less than 2, it will be x square. So that is x square. Limit x tends to 2 minus x square. So 2 square, which is 4. Next, right hand limit, that is limit x tends to 2 plus. So more than 2 values f of x. So it is given already, it is 4. And the functional value f of 2, at 2 the value is 4. Therefore, we can say that left hand limit is equal to right hand limit is equal to the functional value. We can say that at x is equal to 2, the function is continuous. The function is continuous. So, overall by saying this, the function is continuous for every real number. Next, let us look at 8th question. If f and g are continuous functions, so answer is given that f, g are continuous functions. It means that limit value is equal to the functional value. So with f of 3 value is given as 5, so that means limit x tends to 3, f of x is equal to f of 3 is equal to 5. Next, so you have given some condition, let us apply that condition. Limit x tends to 3, twice of f of x minus g of x equals to 4. So we need to find out g of 3 value. So let us apply the limit, constant will come out. So 2 into limit x tends to 3 f of x minus limit x tends to 3 g of x equals to 4. So here limit 2 into limit f of x at x tends to 3 will be 5. So 2 into 5 minus limit x tends to 3 g of x is equal to 4. So it is 10. So limit x tends to 3 g of x can be written as 10 minus 4. So limit x tends to 3 g of x is 6. So it means that g of 3 also 6. Why? Because he has said that f and g are continuous. It means that g is continuous. So definitely the limit value as well as the functional value should be same. So since g is a continuous function, the reason is since g is continuous. Because we got here limit value of 6, so definitely the functional value also should be 6. Then only we can say that they are continuous. Next, let us see the 10th question. A function f is defined as follows. So he has given the fourth condition. He is asking us to take the whether function is continuous. So if you observe the values, we can see only 3 values. At x is equal to 0 we will check first. At x is equal to 1 we will check. Next we will check at x is equal to 3. If at x is equal to 1 if it is continuous, at x is equal to 0 if it is continuous, at x is equal to 3 if it is continuous, we can say that the function is continuous. So let us start doing this. So first at x is equal to 0. At x is equal to 0, we will find out the left hand limit as well as the right hand limit. Left hand limit x tends to 0 minus f of x. So less than 0 value is 0, answer is 0. So right hand limit x tends to 0 plus. So 0 plus f of x. So more than 0 it is x which is 0 if I substitute, or else limit x tends to 0 plus x which is 0. So here left hand limit is equal to right hand limit. We can say that limit x tends to 0 f of x is equal to 0. Now let us take the functional value. So functional value is f of 0. So at a 0, at the point 0, the functional value is x. So if I substitute this, in place of x 0, it will be 0. Therefore, left hand limit is equal to right hand limit equal to functional value. Therefore, left hand limit is equal to right hand limit is equal to the functional value. At x is equal to 0, function is continuous. Function is continuous. Now, let us check it. X is equal to 1. Whether the function is continuous or not. So, to check at x is equal to 1, left hand limit first, left hand limit x tends to 1 minus f of x. So limit x tends to 1 minus, so less than 1 means x only. So if I substitute one value, answer will be 1. So right hand limit next, that is limit x tends to 1 plus f of x. That is more than one value, limit x tends to 1 plus. So more than one value. So we can take this value minus x square plus 4x minus 2. So if I substitute here 1, we are going to get minus 1 plus 4 minus 2. So that is minus 3 plus 4 which is 1. So here left hand limit equals to right hand limit. Left hand limit is equal to right hand limit. So we can say that limit of x tends to 1, f of x is equal to 1. F of x is equal to 1. So let us take a functional value at f of 1. So it will be equal. So let us take a functional value f of 1. So function at 1 value if we are going to take, it is minus x square plus 4x minus 2. If I substitute 1, it will be minus 1 square plus 4 minus 2 which is 3. Therefore, here left hand limit is equal to right hand limit is equal to the functional value which is 1. Therefore, we can say that at x is equal to 1, function is continuous. Function is continuous. Next, another point is that at x equal to 3, we need to check now. At x is equal to 3. So left hand limit first, limit x tends to 3 minus f of x. So at x tends to 3 minus f of x. So less than 3 values are limit x tends to 3 minus x minus x square plus 4x minus 2. So that can be written as 3. So it is minus 3 square plus 12 minus 2. Minus 3 square is 9. 9 minus 9 plus 12 minus 2. Answer is 1. So if you take right hand limit x tends to 3 plus more than 3, f of x is equal to, so limit x tends to more than 3, it is 4 minus x, so that is 4 minus 3, which is 1. Here left hand limit is equal to right hand limit. Therefore, we can write limit x tends to 3, f of x is equal to 1. Now we need to check as a functional value whether it is continuous or not. Now let us check f of 3. So f of 3 means at 3. At 3 means this function we need to use. There is 4 minus 6. So 4 minus 3, which is 1. Therefore, left hand limit is equal to right hand limit is equal to f of 3. We can say that limit x tends to 3, f of x is equal to f of 3. Therefore, at x is equal to 3, function is continuous. Function is continuous. So overall, the total function is continuous. Why? Because at x equals to 0 also continuous, at x equals to 1 also continuous, at x equals to 3 also continuous. So overall the function will be continuous. Therefore, the above function is continuous. Above function is continuous. Next question. Which of the following functions have a removable discontinuity at x equals to x naught? Means if I substitute in case of x not value, whether the function is having discontinuity. If discontinuity is removable, then find a function g that agrees with f for x is not equal to x naught and is continuous on R. So in this we have to find out, we know that the function is discontinuous at x naught is equal to value. If I put minus 2 in this, so minus 2 plus 2 will become 0, the function will be discontinuous. So in this case, we need to remove and we need to find a function which is going to agree this value. So let us find a value which is going to agree. So this is the given function. So we can write this function f of x is equal to limit x tends to minus 2 f of x equals to, okay, first let me check whether it is discontinuous. Limit x tends to minus 2 minus f of x. So we have only one value, so we need to substitute in this. So that is limit x tends to 2 minus x square minus 2x minus 8 by x plus 2. So if I substitute two values in this, we are going to get 2 square which is 4, sorry, minus 2, not plus 2, it is minus 2. So minus 2 square 4 plus 4 minus 8 divided by minus 2 plus 2. So totally we are getting it as 0 by 0, so which is not defined form. We are getting a function which is undefined form. So we can say that it is discontinuous function. So now to check it as a continuous function, let us change this. So how I am going to change here? Limit x tends to minus 2 f of x is equal to limit x tends to minus 2 f of x square minus 2x minus 8 divided by x plus 6. So this can be written as limit x tends to minus 2. So 8 can be written as x square minus 4x plus 2x minus 8 divided by x plus 2. So if I take common in this, we are going to get limit x tends to minus 2. X, if I take common, it will be left with x minus 4. Next plus 2, I can take common x minus 4 divided by x plus 2. So the next step is limit x tends to minus 2, x minus 4 into x plus 2 divided by x plus 2. X plus 2 gets cancelled. So limit x tends to minus 2, x minus 4 is the value. So if I substitute here, if I substitute minus 2 value in this function, so minus 2 minus 4 which is minus 6. So now the discontinuity function we can change like this here. The given function is, so we can write in one statement that, so we have got the answer as minus 6. So removable discontinuity. Removable discontinuity at x is equal to minus 2. At x is equal to minus 2, we can mention with another function g of x is equal to x square minus 2x plus 8 divided by x plus 2, and here minus 6 if x is equal to minus 2, if x is not equal to minus 2. So this is the function to be defined. See the 40th question. The function f of x square minus 1 by x cube minus 1 is not defined at x equals to 1. So it means that answer f of x is given as x square minus 1 by x cube minus 1. So x is not equal to 1. And if I substitute one value, then I am not going to define a function. So we need to mention that x is not equal to 1 that we have given the question. What value we must give to this function in order to make the function is continuous at x equals to 1. So at x equals to 1 only we have to make the function as continuous, but we need to substitute what value is asked in the question. So let us take the function first. F of x is equal to x square minus 1 by x cube minus 1. Let us apply the limit first. So if I apply the limit, look at here, limit x tends to 1. Why I am applying 1? Because the value is 1. F of x is equal to limit x tends to 1, x square minus 1 by x cube minus 1. So limit x tends to 1, x square minus 1 square can a square minus b square can be written as a minus b into a plus b. Here a cube minus b cube can be written as a minus b into a square plus ab plus b square. So x minus 1 gets cancelled. We can write it as limit x tends to 1, x plus 1 divided by x square plus x plus 1. So if I substitute the value now, if I substitute the value 1, so 1 plus 1 which is 2 divided by 1 square 1, so it will be 3. So I am getting that limit x tends to 1 f of x is equal to 2 by 3. So it means that f of 1 value is 2 by 3. Since the function is continuous, then we can write that limit value is equal to the functional value. Therefore, the f of 1 value is 2 by 3.